So, first of all, good afternoon, everyone. Welcome you all for NDA lecture. So, first we can, within 5 minutes, we can discuss what we have covered in the previous lecture. So, in the previous lecture, we have completed the equations for filter networks. And after that, we have discussed about what do you mean by the constant K-type filter. Okay, why these passive filters are named as or so those points we have discussed. And after that, we have started the first constant K type filter, that is the constant K type low pass filter. That part we have completed, and based on that, we have designed also uh, low pass filter. We have designed which is of type constant K type. That is the in through the numerical problems we have solved. So two examples we have solved how to design the constant K type low pass filter. So this part we have completed in the previous lecture. I will share that what we have covered. I think the screen is visible. Yes.
Yes,
Yes.
sir.
Yes, sir.
So constant K type filter, why it is why the passive filters which we are going to design or which we are going to learn in this chapter, those are called as constant K type if it follows the following relationship. So what is the relationship? Z1 and Z2 of the filter network satisfy the following relationship. That is the Z1 into Z2 is equal to K square, where Z1 is impedance in series arm of either T or pi. Then Z2 is the impedance in parallel arm, or we can call it as shunt arm of the T or pi filter network. K is the constant value. The name of K will be design impedance, nominal impedance, characteristic impedance, load impedance, etc. So actually we are in the filter equations, we are taking all these by Z0. So Z0 is replaced by here K. Okay. So K and Z0 both are same here. Now next, after that, we have started the constant K type low pass filter. So constant K type low pass filter in that T section and pi section, it is applicable for each and every filter, T section and pi section. So in the series arm, inductor is there. That you have to remember. In the series arm, only inductor will be there for low pass filter. And in the shunt arm, capacitor will be there. Okay. Based on that, you can remember the diagram. So if it is only one, you can take L. If here capacitor is only one, you can take C like this. If two inductors are there in the series arm, obviously we have to make it L. So for that, L by 2, L by 2. In this logic, you can remember the diagram. So two capacitor, if you are connecting parallel, so when you can get C, when you are dividing C by 2, C by 2. कारण जेव्हा दोन कॅपॅसिटर पॅरलल असतात तेव्हा त्यांची ऍडिशन होती. Okay. Next one, we have proved that why this low pass filter is called as constant K type. We have proved. So series impedance we have taken Z1 J omega L. Shunt arm impedance we have taken J upon omega C. We have taken the magnitude and product we are getting L by C. So L by C is the constant, that is K square. So in this way we have proved that this low pass filter is called as constant K type. So after that, design equations, two design equations are important with respect to inductor L and in a capacitor value C. So these formulas, if you are remembering, then all formulas in this chapter related to filter, you can easily remember. So logic I will at the end of all filter section, all filter part, I will tell through the table. I will tell how to remember the logic and what are the relationship between formulas of each and every filter. But basic is what? Low pass filter. That is L is equal to K by pi FC, and C is equal to K. You can take in the denominator 1 upon K into pi into FC. For everywhere for inductor, the K value is in numerator. And for capacitor, the K value is in denominator. That you can remember. That is another one logic. इंडक्टरच्या फॉर्म्युलामध्ये के न्यूमरेटरला असणार आणि कॅपॅसिटरच्या फॉर्म्युलामध्ये के डिनॉमिनेटरला असणार. That you can remember. So here K is nothing but what? Load impedance, characteristic impedance, all those. And FC means what? FC is the cutoff frequency of low pass filter. Similarly, FC is cutoff frequency for high pass filter. But for band pass and band stop, there are the two cutoff frequencies, F1 and F2. F1 is lower and F2 is upper. Next, after that, we have solved the example. This is the first example, numerical example we have solved. So design a constant K-type low-pass filter having cutoff frequency 2 kilohertz with load impedance of 500 ohm. So K is 500 ohm, FC is equal to 2K. We have taken. We have used the formulas and got the L and C values. And after that, we have drawn the diagram of low-pass filter T section and pi section. We have mentioned all those values in that diagram so that we can complete the entire design of constant K-type low-pass filter. So similarly, second example we have solved by changing the value of cutoff frequency and load impedance. That's it. Okay. So this up to this point we have covered in the previous lecture. So now we can start the next filter. So which is that? Anyone? Which filter we are going to start today? Yes. Which filter we are going to start today? Anyone?
Constant K-type high-pass filter.
Yes, very good. So constant K-type high-pass filter today we are going to start here. So first of all, we can start why it is called as constant K-type again. So same again we have to prove. So there is no need to prove this. Okay, because again in the only the position of the inductor and capacitor will change. The product remains same. Are you getting my point? फक्त इथे सिरीज आर्म मध्ये काय असणार आहे कॅपॅसिटर आणि शंट आर्म मध्ये काय असणार आहे इंडक्टर. दॅट इज ओनली डिफरन्स. सो नेक्स्ट विल बी द कॉन्स्टंट K type high pass filter. Constant K type high pass filter. Constant K type high pass filter. So we can start with some point here. How we are going to form the constant K type high pass filter. Constant K type high pass filter, HPF I will write. Constant K type high pass filter can be obtained by changing the positions of elements L and C in low pass filter. लो पास फिल्टरचं एक्झाम्पल घ्या. त्याच्यामधून तुम्ही इंटरचेंज केलं. चेंजिंग द पोझिशन मीन्स इंटरचेंजिंग वी कॅन से exchange, interchange, whatever the word you can use. Interchange the positions of elements L and C in low pass filter so that you can get the constant K type high pass filter. So diagram I will draw T section and pi section. Now you can tell what will be the value of capacitor here in case of T section and pi section. Inductor value and capacitor value. You have to tell now value. Value means what? In terms of capacitor value. I'm not asking exact value because we are not considering any numerical example. So this is what T section, first one, T section, and this is what pi section, T section and pi section. So this is what figure we can consider figure 2. Okay, so figure 1 we can consider it in constant, or with respect to this point you can consider figure 1. Okay, no problem. So this is here constant K type high pass filter. Okay, now what will be the names? If inductor 1 is there, obviously only L will be there. Here capacitor 1 is there, only C will be there. There is no problem here. But what about this values? Two capacitors are connected in series, but we want only C value.
C by 2, C by 2.
No, C by 2 addition will not happen no in series. जेव्हा कॅपॅसिटर सिरीज मध्ये होतात त्यांचं ते पॅरलल कॉम्बिनेशन होतं.
1 upon
No, I want
2C,
the equivalent value as a C.
2C, 2C.
Yes, very good. So 2C is in parallel. Is actually, if they are series, in their series, 2C and 2C in series means we have to take the equivalent capacitance CT is equal to 2C into 2C. म्हणजे पॅरलल ज्याला जसं घेतो तसं घ्यावं लागेल. 2C into 2C plus 2C plus 2C. Okay, so 4C square divided by 4C. So this C will get cancelled. 4 will get cancelled. So CT means total equivalent becomes C. So that's I want. So 2C and 2C are in series when they are connected like this. Then and then you can get the C. So here the value of this capacitor is 2C and this is the 2C. Now understood? Everyone? Okay. Now next thing, in case of pi section, two inductors are connected in parallel or in shunt. What will be the value of inductor then? Inductors.
2L and
मला
2L.
इथं दोन. Yes. So both inductors are connected in L parallel. So here the value I need equivalent inductance I need L. So what will be the value here? Once again.
2L and 2L.
Yes, very good. So it is 2L and 2L. So two inductor having value 2L, 2L, if they are connected in parallel, then the value will be half. That is a L. So that's why in this logic also we can remember the value of each and every element. Are you getting my point? पहिलं काय लो पास फिल्टर आणि हाय पास फिल्टरचा डायग्राम कसं लक्षात ठेवायचं? Anyone? How to remember the diagram? How to remember the diagram? T section. Chalo, T section you can tell. I will draw here. You can tell for low pass filter. In the series arm, which element is there? Which element is there first of all?
Inductors.
Yes, in series arm, two inductors like this, and in parallel arm, shunt arm,
Capacitors.
capacitor. Okay. Okay, this is T section. We can call it as T section low pass filter. Next value. If only one is there, C. If two inductors are there, what will be their value? Two inductors in series.
L by 2 and L by
L
2.
by 2. L by 2. बरोबर आहे? So for low pass filter, inductors are in series and capacitors are in parallel in shunt. In case of high pass filter, capacitors are in series arm, and inductor are in shunt arm. That you can remember. In this way, you can remember all the diagrams and values. There is a logic. Logically, if you are remembering, you cannot forget. तुम्ही practice-नी करू शकाल, but practice will help only for some period. But if you are remembering by logical way, you cannot forget. Are you getting my point? Practice केलात तर exam point of view exam पर्यंत तुम्हाला नंतर तुम्ही ते विसरून जाल. But if you are remembering by logic way, in this diagram is like this, there is this value like this. Like if you are preparing, then you cannot forget the diagram values and equations and formulas. Are you getting my point? So next, T section and pi section we have drawn for high pass filter. So there is no need to prove here, because for capacitor again 1 upon j omega c, and for inductor j omega, take the multiplication again, you will get the same answer, that is a L by C. L by C only you can get, and that is called K square here. Same proof will be there. So I will write here just the high pass filter is of type is of type constant K type. Constant K type because Z1 into Z2 is equal to K square, that is equal to L by C. Okay, that is where you can mention Z1 is equal to what is the element in the series arm. So that is with respect to omega C. Okay, so with respect to T you can take. So Z1 is equal to J upon omega C, and Z2 is equal to J omega L. Sorry, the J in na 1 upon J omega C, and Z2 is J omega L. So you can take the product. If you are taking the product, it will get what? L by C. Now next point, design equations. Design equations for high pass filter. Design equations for constant K type high pass filter. Constant K type high pass filter. So what will be the first formula? Series arm element or shunt arm, any you can take. So suppose I am taking the shunt arm, that is L. L is equal to what will be the formula? K divided by 4 pi FC. So this is my first equation. So I told that for inductor, K value is always in the numerator. That logic you can remember. Next, C is equal to whatever the inductor value is there. Inductor formula is there. Just K take in the denominator. So 1 by 4 pi K FC. So this is my second equation. So third equation is same. That is K is equal to under root L by C. Okay. So here inductor L is what? Inductor L is what? Shunt arm element. Shunt arm element. This is what? Series arm element. Series arm element. So if I know the L formula, I can easily write the formula for capacitor. Just K take in the denominator. But how to remember the equations of constant K type based on the equations of low pass filter? What is the difference? Yes. So I will here write the equations of low pass filter. So L is equal to K upon pi FC, and C is equal to, just take K in the denominator, K pi FC. So I want to check the relationship between this L value for high pass filter and this L value for low pass filter. What is difference here only? Reply fast. What is difference? Are you understand what I am saying? Everyone?
In L, K is in numerator, and
Yes.
in capacitor, K is in denominator.
Okay, that's good. But I am asking the difference between formulas of L in case of high pass and in case of low pass. What is difference?
4 is there.
1 upon.
Yes, 4 is there. And 4 is where? In the denominator. बरोबर है कि नहीं?
Yes, sir.
Yes,
Okay.
sir.
So low pass filter equation is there. I want to get the equations of high pass filter. So just I will multiply 4 in the denominator. Here also and here also. So I can get now equations of high pass filter then. Logic is there, no? To remember the formula is based on low pass filter. Yes or no?
Yes, sir.
Okay. So there is no need to by heart or mug up all formulas. सगळे फॉर्म्युले लक्षात ठेवायची गरज नाही, फक्त तुम्हाला रिलेशन्स आणि लॉजिक लक्षात ठेवायचं. Yes or no?
Yes, sir.
Total 18 formulas are there in this chapter. So it is not easy to remember each and every. So if you are trying to remember, you will mix up and you can get new formula. Are you getting my point? So logically you can remember. So at the last of filter part, I will tell how to remember each and every formula through summary table. Okay. Sure. So next we can start to solve the numerical example. So any questions from these points, this theoretical point? If any questions will be there, you can ask. I will give 30 seconds for you people. Read each and every point and ask the question.
सर कॉन्स्टंट के टाइप फिल्टर लो पास फिल्टर मध्ये Z2 ची व्हॅल्यू 1 J बाय ओमेगा सी कसं किती?
Where?
कॉन्स्टंट के टाइप लो पास फिल्टर मध्ये Z2
Yes.
ची व्हॅल्यू मायनस J बाय ओमेगा सी घेतली, ती कशी घेतली?
Yes. So I will draw the low pass filter for T section we can take. Here it is L by 2. This is of low pass filter, no? And this is what? C. Okay. Now, first of all, XL means what? J omega L किंवा असं लिहू शकतो, बरोबर आहे? So J omega into L. No problem for XL. Now next, because series arm inductor is there. For inductor, the impedance is XL. So XL is nothing but what? J omega L. Now what about capacitor? XC. XC म्हणजे काय?
1 of
1 J ओमेगा सी.
1 upon
J ओमेगा सी.
1 upon J omega C. So 1 upon J omega C, if you are taking 1 upon J omega C. Okay. So this suppose I have taken the magnitude. मग ह्यांचं प्रॉडक्ट जरी घेतलं तर J कॅन्सल होईल, ओमेगा कॅन्सल होईल, L डिवायडेड बाय C आन्सर येईल तुमचा, बरोबर आहे? इन दिस वे ऑल्सो यू कॅन डू. बट सपोज यू आर टेकिंग लाईक दिस मॅग्निट्यूड इफ यू वॉन्ट. ओके. ऍक्च्युली आपण कसं घेतो, असं पण घेऊ शकतो. 1 upon J into omega C is same as, आता दोन्हीकडे मी समजा मल्टिप्लाय केलं J नी, तर काय होईल? सो दिस बिकम्स J, दिस बिकम्स J into J स्क्वेअर म्हणजे मायनस, minus omega C. So minus J upon omega C. This we have taken yesterday. बरोबर आहे?
Yes sir.
Okay. So these are again we have taken the mod. So mod of XL, mod of Z1 म्हणूया आपण, ह्याला Z1 म्हणूया आणि ह्याला Z2 म्हणूया. So Z1 mod into Z2. So what is that? So mod if you are taking, that is J omega L into this negative goes. Okay. किंवा असं ऍज इट इज मॉड म्हणण्यापेक्षा आपण इथं मल्टिप्लिकेशन म्हणूया. मल्टिप्लिकेशन केलं तरी तुमचा आन्सर येईल. Z1 into Z2. Z1 चं काय असणार आहे? J omega L into minus J upon omega C. Okay. So omega will get cancelled. J into J किती होणार आहे?
J स्क्वेअर.
J स्क्वेअर आणि मायनस ऍज इट इज आहे, मायनस J स्क्वेअर into L by C. So what is J square?
-1
So minus of -1, what is?
plus
Minus of -1 into L by C. So what is happening? L by C. कसंही करा, answer L by C च येणार आहे. If you are taking directly, you can take otherwise in this method. So better way, you can follow this. XL is j omega L and X is 1 upon j omega C. Simply multiply it. J cancel, omega will get cancel. Answer will be L by C. Now clear?
Yes, sir.
Okay. Now we can move towards the solving the numerical examples. We have to cover 2 examples today based on the high pass filter. So one example is with me now. Second example you have to solve now. First example I will tell how to solve. Question number 1. Design a high pass filter. Design a high pass filter of constant K type. Constant K type having a cutoff frequency of 1 kilohertz with load impedance of 600 ohm. This is the question. Design. This question will ask for 4 marks. Design a high pass filter of constant K type having cutoff frequency of 1 kilohertz with load impedance of 600 ohm. So what are the given things? What are given things?
FC and K.
Yes, FC and K value. So constant K type high pass filter we have to design. Most of the students are in hurry. They are not reading the which filter they are going to design. Just they can take constant K type, frequency 1 kilohertz, load impedance 600, and they can start the low pass filter. But what is the question? You can read properly, no? So if they are asking high pass filter, how you can design the low pass? Are you getting my point? So read the question properly, write down the given data properly, and then you can start to think how to draw the diagram, how to write the formulas and get the answer by putting the values of whatever the given FC and impedance K value like this. So constant K type high pass filter, the value given K as 600 ohm and FC is given as 1 kilohertz. Okay. Now next point, the low pass filter. How we design in the same manner we can design the constant K type high pass filter. First, either we can find out all the values of L and C, and then you can draw the diagram and mention the values. Otherwise, first draw the diagram, then find out the values, and then mention in the diagram all values. So it depends on you people. So first I will going to find out the values. Now the shunt arm I will get formed. First of all, the shunt arm element, that is the L of high pass filter is the shunt arm element L of high pass filter is. So L is equal to K upon 4 pi FC. So this is my formula to calculate the L value. So K is what? 600 divided by 4 pi into 1K. So don't cancel again K and 1K like this. Many students are doing this. Okay, FC तो 1K ठेवतात आणि K cancel करतात. So calculate and tell me what is the value of L you are getting here.
47.74 millihenry.
So 47.74 millihenry. If you are not able to judge how milli will come, you can just mention like this 47.74 into 10 raised to minus 3 Henry. This is also acceptable. Huh? You can try to convert milli, micro, nano. It is better because we have to mention the values in the diagram also. So instead of mentioning this lengthy one, we can easily mention this one, so that you can remember. So second one, the series arm element. The series arm element C of high pass filter is C is equal to 1 upon what? 4 pi k into FC. So put the values and find out the answer here. 1 upon 4 pi into k is what? 600 into 1 kilohertz. So C value I need to calculate. So C value
in microfarad.
how much? Can you repeat once again? What is the value? Anyone?
One 132.69 nanofarad.
132.69 nanofarad. Okay. 132.9 means 133 almost. 133 nanofarad. Or if you are keeping in microfarad, you can get 0.133 microfarad. So both answers are acceptable. 133 nanofarad or 0.133 microfarad. Everyone getting same answer?
Yes, sir.
Yes, sir.
Okay. So we need to draw the diagram of T section and pi section. That is the third point now. So here capacitor C, inductor L is in shunt arm. For pi section, the capacitor C is in shunt arm. So like this. So 2C, this is the value of L. Here it is C. This is 2L and this is 2L. So T section is here. T section. And this is the pi section. Is here. So this is what figure that is of constant K type. Constant K type high pass filter. Constant K type high pass filter here. So mention the value of L and C easily. Here we can mention 47.74 millihenry for inductor L. For capacitor here 0.133 microfarad, or you can mention 133 nanofarad. Next 2C. 2C means double of this. Calculate. Can I get 0.266 microfarad? Yes, 0.266 microfarad. 0.266 microfarad. For 2L
95.48.
95.48 millih. 95.48 millih. Okay, so this is what how to solve the design problem based on the high pass filter, constant K type high pass filter. So formulas are required. Calculation is 100% required. बरेच मुलांना फॉर्म्युला येत असतं, डायग्राम येत असतं, पण कॅल्क्युलेशन चुकतात. So if you are getting wrong answer, you can get the less marks. For formulas, if you are correct, you can get some marks. Formula चुकलं तर सगळं चुकणार. Diagram also you have to remember properly. Many students are drawing the diagram of low pass filter for high pass. For low pass, they are drawing the filter high pass filter. Low pass ला high pass चं काढतात, high pass ला low pass चं काढतात. Whatever they want, they can draw. But it is not like this. You have to draw the diagram with respect to particular filter only. So read it. I will give 1 minute for everyone so that you can understand this example, and I will give the second example now. So let's start the second example. Any questions with respect to this example?
No, sir.
Okay. So take a second example. Now answers are not with me. You have to calculate and you have to tell. Question number 2. This is the new example. Design a constant K type high pass filter having a cutoff frequency of 10 kilohertz and load impedance of 500 ohm. So how to start now? As usual, you have to mention first of all which type of filter you are going to design, then mention the given values in the question. We are going to design the constant K type high pass filter. K value is given and FC value is given. So K value is what? How much?
500.
Yes, 500 ohm. And this FC value is given
10 kilohertz.
10 kilohertz. FC value is 10 kilohertz. So first of all, we can start to find out the value of shunt arm, that is the L value. The shunt arm element L is given by the shunt arm element L is given by L is equal to, anyone can tell formula now?
K upon 4 pi
Upon
FC.
Yes, K upon 4 pi FC. So put the values. K is equal to 500 divided by 4 pi. FC is what? 10 kilohertz. Calculate and tell. Everyone mention the values.
3.98
How much?
3.98 millihenry.
3.98 millihenry. So 3.98, almost 4. So mention everyone in the chat box what are the values you are getting. I will see how many of you got the answer. How many of you are solving really? Only 2 students mentioned. Okay, 3, 4. Very good. What about others? Okay, so everyone is getting 3.98 nearly. Okay, millihenry. So this is what the value of inductor L. So next what? Second thing, that is the series arm element. The series arm element, that is the C of high pass filter, is C is equal to what we have to do with respect to inductor formula, just a K take in the denominator. So 1 upon 4 pi KFC. So 1 upon these all values you can mention and find out the answer of C. 1 upon 4 pi into 500 into 10K.
0.015 microfarad.
0.015
Yes, sir.
Yes, sir.
microfarad.
Microfarad.
Micro or nano?
Micro.
Yes. So everyone mention values once again in the chat box. Those who got the answer. Only 20-25 students are doing a calculation. What about others? Whether you don't have the calculator with you, I told yesterday only. You must have calculator along with you for NTA lecture now. Microfarad, yes, 0.015. 15.9 nanofarad. That is also acceptable. So 0.0159 is there. So we can take 0.016. 159 means the left hand side digit will upgrade. So 0.016 microfarad. That is nothing but 60 nanofarads. Okay, nearby value we can take 0.0159 means 16. So we can start for designing the T section and pi section. This is what T section. This is 2C and inductor L. This is C, this is 2L, and this is 2L. This is T section. This is pi section. This is the figure. Constant K type high pass filter. So value you can mention. L is simple 3.98 millih. C value is here 0.016 microfarad. What about 2C and 2L? 2C and 2L 0.032. That is for 2C. बरोबर आहे 0.032 microfarad. That is the value of 2C. Zero point 0.032 microfarad. 0.032 microfarad. What is about 2L?
7.96.
7.96 बरोबर आहे 7.96 millihenry. 7.96 millihenry. This is what design of constant K type high pass filter. So very simple. ह्याच्यात काय जास्त डोकं लढवायची गरज नाही. We need to know only the correct formulas, correct diagram and correct calculation. Just like how to solve the example in the first chapter, that is network theorem किंवा two-port networks. Those are the complicated as compared to this type of examples. Yes or no? Which problems are simple? First chapter problems or these? Okay. So any questions from these today's two examples we have covered, and we have completed the constant K type high pass filter today. In the next lecture, we are going to discuss the next filter, that is the band pass filter. So there is one derivation. That derivation is important because the derivation asked in the university question paper. So theoretical part is too much in case of band pass filter. So today, tomorrow or in the next lecture, we can start the constant K type band pass filter. One derivation we have to consider, then numerical examples, and after that constant K type band stop filter. Okay, if no questions, we can stop for today. Okay.